In this session, we're going to look at more factoring. We saw factoring can be viewed as an area problem. When we have something like x squared plus 8x plus 15, we can view this as one flat x by x. So the area here is x squared. We have 8 rods, 1 by x. So the area of each of those rods is x. And we have 15 tiles, 1 by 1 tiles. The area would be 1. The goal is, can you rearrange 1 square, 8 rods, and 15 tiles? Can you arrange these objects to form a rectangle? The answer depends on whether x squared plus 8x plus 15 is factorable. If it is factorable, then you will be able to arrange those objects into a rectangle. And it won't make a difference whether we have a rectangle that's oriented like this, vertically, versus horizontally. That if this area and that area are the same, it won't make a difference which way you arrange the factors. To see that, if you have a sheet of paper, 8.5 by 11, and you hold it in portrait mode, that has the same area if you turn it to landscape mode and have 11 by 8.5. So when we see this as a rectangle, where this side right here is x plus 5, and this side right here is x plus 3, that's going to be the same as having the other rectangle, having the side down here, x plus 3, and length, x plus 5. Those two areas would be the same. The key to factoring is to figure out how to rewrite that expression in such a way that when you factor by grouping, it will work out. If we write x squared plus 8x plus 15 as x squared plus 5x plus 3x plus 15, then look what happens when we group the first two terms together. We group the first two terms together and we can factor out an x. And there is an x plus 5 left behind. Grouping the second two terms together, we can factor out a 3. And an x plus 5 is left over. And now you see a binomial factor in common. And that binomial factor can factor out as x plus 5. And then what's left over would be an x plus a 3. And there we have our factoring, x plus 5 times x plus 3. And it doesn't matter how you rearrange the 8x, whether you write it as 5x and a 3x, like we did, or if you write 8x as 3x plus 5x. So if we have x squared plus 3x plus a 5x plus a 15, we will still get the same answer. The only difference would be when you group the first two terms together, you can factor in an x, and an x plus 3 is left over. And then grouping the second two terms, you factor out a 5, and an x plus 3 is left over. And then that gives us x plus 3 times x plus 5 as the solution. Multiplication is commutative. So the question here is, why did we write 8x as 5x plus 3x? There are plenty of ways to rewrite 8. 8 can be 1 plus 7. 8 can be 2 plus 6, or 4 plus 4, or 9 minus 1. But there's only one way to rewrite it so that we can factor x squared plus 8x plus 15. The answer is when we look at 15. What are the factors of 15 which combine to give 8? So 15 can be written as 1 times 15, negative 1 times negative 15, negative 5 times negative 3, and positive 5 times positive 3. And that's the combination that we need. We needed that 5 and 3. In general, to factor a monic quadratic, that means that things that look like this, x squared plus px plus q, where the leading coefficient is a 1, that makes it monic. Or if we can make something look like that, then we will be able to factor using this method. The first step, find the factors of that last term q, which combine to give the middle term p. And then the second step would be to rewrite the middle term, replacing px by those factors found in step 1. And then step number 3 would be factor by grouping. Suppose that we found the factors of Q. Suppose Q is equal to some number A times some number B. At the same time, that number P is A plus B. Then we can rewrite x squared plus px plus q as x squared plus parentheses A plus B times an x plus AB is the Q term. And now using the distribution property on the middle term there, we can have x squared plus AX plus BX plus A times B. And if we pair up the first two terms, we can take out an x, and x plus A is left over. The second two terms, you take out a B, and an x plus A is left over. And then you have a binomial factor in common. X plus A times x plus B would be the solution to the problem. X squared plus 10x plus 24. So we're asking ourselves, what are the factors of 24 that add together to give you 10? Well, 24 is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. There are plenty of ways to make a 24. There's only one combination where the two factors of 24 will add together to give you 10, and that is 24 is 6 times 4, and at the same time, 6 plus 4 makes that middle term 10. So the pair of numbers has to do two things: multiply together to give one particular number, and add together to give a required number. And there will be only one combination that works if it's factorable. Right? It's going to be a unique combination. Step number 2 would be to rewrite x squared plus 10x plus 24 as x squared plus 6x plus 4x plus 24. And now when you group together the first two terms, we can factor out an x, and an x plus 6 is left over. Group the second two terms, you can take out a 4, and an x plus 6 is left over. And then finally you take that binomial factor out, and you have x plus 6 times x plus 4 as the solution to the problem.